Right now, somewhere in America, a truck is being towed into a service center. The driver doesn't know it yet, but he is about to be handed a repair estimate for $2,300. New transmission control module, new throttle body, maybe an ECU reflash, hours of labor. And here is what is going to happen. He is going to pay that bill. The truck will drive fine afterward. Everyone is going to think the system worked. It didn't. Because the parts they are about to replace, nothing was wrong with them. The metal was fine. The sensors were healthy. The electric motors were perfectly intact. The entire failure was a ghost. What actually happened is that the engine computer just got confused. It forgot how to talk to its own hardware. It panicked, dumped its memory, and reverted to factory settings that haven't matched the physical reality of that engine in over 100,000 miles. The sensors started lying to it. The fuel trims went haywire. The truck started running like garbage. And instead of spending 90 seconds doing a factory-specific reset procedure to teach the computer how to use its own parts again, the shop just bolted on brand new modules. Because new parts force the system to start fresh anyway, the problem disappears. The mechanic thinks the new part fixed it. The customer is out $2,000. And the perfectly good original part gets tossed into a scrap bin. This happens every single day, across every single brand. And the worst part is, the guys writing those repair orders aren't even doing it on purpose. They just don't know the procedure I am about to show you. In the next 30 minutes, I am going to walk you through the exact 90-second reset procedure that factory technicians use. The one that wipes the engine computer's adaptive memory, forces it to relearn its 0 point, and fixes phantom fuel trim issues, rough idle problems, hesitation under load, and that maddening intermittent check engine light that no scanner can pin down. This is not an illegal hack. You are not bypassing emissions. You are not tricking a safety system. This is a factory-engineered sequence designed for technicians, hidden inside the service manual that the dealership counter never tells the customer exists. It works on most OBD2 vehicles built after 1996. If you understand what I am about to show you, you are going to save a pile of money the next time your car starts acting strange. You are going to avoid completely wrong diagnostics, and you are going to finally understand why your car does the weird things it does after the battery dies, after a sensor swap, or after a cold morning. Before we dig into the actual procedure and I show you the exact button sequences, I am actually curious about something. We have guys turning wrenches in their own driveways watching this channel from all over the place. Drop a quick comment down below and let me know what you drive. Year, make, model. I read every single one of these. It helps me know what to cover next, and honestly, it just blows my mind seeing how many of you are out there keeping these machines alive. And if you end up learning something today that saves you a massive diagnostic fee later down the road, do me a favor and hit that subscribe button. It genuinely helps me keep making this kind of stuff. That is the only ask. To understand why a 90-second procedure can fix a problem that costs $2,000 at the dealership, you have to understand what is actually happening under the hood when you turn the key. Your car does not have one central brain. It has dozens of them, all talking to each other over a network called the CAN bus. Think of it like a high-speed group text message. Every module needs to know the exact physical position of every part it controls. And the most important brain, the one we are going to focus on today, is the ECU, the engine control unit. This is the module that decides how much fuel goes into your cylinders, when the spark fires, how the throttle opens, and how the engine responds when you press the gas pedal. Here is the part most people don't understand. When your car rolls off the assembly line, the ECU has a baseline map, a factory calibration. But the moment you start driving it, the car begins to learn. The metal inside the engine wears down by microscopic fractions. Carbon builds up inside the intake. The oxygen sensors age. The transmission fluid breaks down. The ECU watches all of this happen in real time, and it adjusts. It changes the fuel trims to compensate for a slightly leaky injector. It bumps up the idle speed to push past a dirty throttle valve. It adjusts the ignition timing to prevent knock when the gasoline quality drops. It adapts. It stores all those modified numbers in its volatile memory. But here is the fatal flaw in this beautiful engineering. That adaptive memory is fragile. Let's say it is the middle of winter. Your battery is 5 years old. You go out to start the car in the morning. The starter cranks slow. The headlights dim. The dashboard flickers. The engine finally fires up. In that 3-second window where the starter was struggling, the voltage in the entire car dropped down to maybe 8 or 9 volts. Computers hate low voltage. The data inside the ECU's volatile memory got scrambled. The adaptive parameters got corrupted. Suddenly, the engine computer forgets that the throttle body is dirty. It reverts back to factory settings. But the throttle body is still full of carbon. Now the car won't idle. It stalls at stoplights. The check engine light comes on. The system throws itself into limp mode, severely cutting your power. You limp the car to a shop. The mechanic plugs in a scanner, sees a code for the throttle position sensor, and says, "Yep, you need a new throttle body. That'll be $600 with labor." He is dead wrong. The throttle body is fine. The battery voltage just dropped. The memory wiped. The sensor lost its reference point. This exact same thing happens when you do your own maintenance in the driveway. You change a battery. You clean a throttle body. You swap a fuel injector. You replace an oxygen sensor. The hardware is now correct, but the computer is still applying its old adaptive parameters to brand new equipment. The math doesn't match the metal, and until you teach the computer to forget what it learned, the car is going to keep running like garbage. So how do you actually do this? How do you wipe the slate clean without losing your radio presets, without scrambling your transmission, without making everything worse? There is a very specific way, and it depends on what you drive. Before I get into the brand-specific button sequences, I want you to understand the underlying principle, because every manufacturer does this slightly differently, but they are all doing the same thing. The procedure forces the engine computer to drain its temporary memory, find its 0 points again, and rewrite its adaptive tables from scratch. It takes 90 seconds of your time, sometimes less. Let's start with GM. If you drive a Silverado, a Tahoe, a Sierra, an Equinox, anything from GM built in the last 15 years, this is one of the simplest procedures in the entire industry. You turn the key to the on position. You do not start the engine. You leave it sitting there with the dashboard lights on for exactly 3 minutes. That is it. During those 3 minutes, the computer is doing something incredible behind the scenes. It sweeps the throttle valve from fully closed to fully open. It feels exactly where the physical metal stops are. It writes those new positions into its memory. It checks the idle air control. It zeroes out the fuel adaptations. After 3 minutes, you turn the key off. Wait 10 seconds. Start the truck normally. The idle is going to be smooth as glass. Now here is the part most YouTube videos get wrong. They tell you to disconnect the battery for 15 minutes and call it done. That works for some things, but it is the nuclear option, and I am going to explain in a few minutes why you should almost never do that. Toyota does this completely differently. On most modern cameras, RAV4s, Tacomas, and Highlanders, the procedure involves what I call the pedal dance. You turn the ignition on without starting the engine. You wait exactly 3 seconds. You then pump the gas pedal to the floor 5 times within 5 seconds. You wait 7 seconds. Then you hold the pedal down to the floor until the check engine light starts flashing. Hold it there. The flashing stops. Release the pedal. It sounds like a cheat code for a Nintendo game, but I promise you, this is the actual factory procedure. It is in the Toyota service manual. The flashing light is the ECU acknowledging that you have entered the relearn mode. The instant the pedal goes down, the computer dumps its short-term and long-term fuel trims, resets the idle air, and prepares to learn from scratch. Honda is similar but cleaner. On most Civics, Accords, CR-Vs, and Pilots, you turn the key to the on position. You wait 5 seconds. You then disconnect the negative battery cable for 10 seconds. You touch the loose negative cable to the positive terminal for 30 seconds, which discharges the residual voltage in the capacitors across the entire CAN bus network. You reconnect the negative cable. The Honda boots up with a completely clean adaptive memory. Board makes you work a little harder. On a lot of F-150s, Explorers, and Edges, the relearn requires what they call a key cycle. You turn the key from off to run 3 times, with 3-second pauses between each cycle. Then you press and hold the brake pedal. Then you cycle the key 3 more times. The horn honks once. That honk is the module acknowledging you are in service mode. Now you start the truck. Let it idle for 3 minutes without touching anything. The ECU sweeps through its baseline parameters, finds the throttle stops, recalibrates the idle air, and writes new adaptive values into its memory. After 3 minutes, drive the truck normally for about 20 minutes at varied speeds. Highway, city streets, some stops. The computer finishes the relearn during driving. Dodge and Jeep use a similar process, but the trigger is different. You hold the gas pedal to the floor while turning the key from off to on. You hold it for 30 seconds. You release the pedal. You turn the key off. That is the unlock command. From there, you start the engine and let it idle for at least 5 minutes. Now, all of these procedures work. They work because the engineers who designed your car put them there on purpose. But there is a specific situation where the reset will fail, where you will do everything correctly and the car will still run like garbage afterward. And it has happened to me in the shop more times than I can count. Let me tell you about a guy who came in last summer. Older gentleman. Real nice guy. Drives a 2016 Ford F-150. He takes care of that truck like it is his second child. Detailed every weekend. Oil changes every 5,000 miles. Cleaner than my own truck, honestly. He pulls into my shop on a Tuesday afternoon looking physically stressed out. He hands me a printed estimate from the local dealership. $2,347.16. They had quoted him for a new throttle body, a new mass airflow sensor, an ECU reflash, and 4 hours of labor. He tells me the truck started acting weird about a week ago. The idle was bouncing, anywhere from 600 RPM to 1500, just hunting up and down. The check engine light came on intermittently. Sometimes it would stall at red lights. Other times it ran perfect. The dealership scanned it, found a code for throttle body adaptation out of range, and quoted him for the entire intake system. Now, I have seen this exact symptom maybe 300 times. It is one of the most common pseudo-failures in modern engines, and 9 times out of 10, it has nothing to do with the throttle body itself. So I asked him one question. I said, "Did you do anything to that truck in the last 2 weeks? Any maintenance? Anything at all?" He thought for a second, and then he said, "Well, I changed the battery. The old one was 4 years old. I just dropped the new one in myself in the driveway last Saturday." There it was. The entire $2,300 problem in one sentence. When he disconnected the old battery, the ECU lost its volatile memory. When he connected the new one, the engine fired up using factory baseline calibrations from 2015, applied to a 120,000-mile engine. The fuel trims were wrong. The throttle adaptations were wrong. The idle reference was wrong. The truck was running on math that was 8 years out of date. I told him to leave it. I would call him in a few hours. He looked nervous. I think he thought I was about to charge him $1,000. I walked the truck into my bay. I did not pick up a wrench. I did not unbolt anything. I did not order any parts. I plugged my scan tool in. I navigated to the engine control module menu. I selected the option labeled Clear Adaptive Memory. I confirmed it. The screen blinked once. Took about 3 seconds. Then I unplugged the scanner. I sat in the driver's seat. I turned the key to the run position. I waited exactly 3 minutes while the computer ran through its self-calibration sweep. I turned the key off. I started the engine. It idled at 650 RPM, steady as a metronome. No bouncing, no hunting, no check engine light. The truck purred. I drove it around the block, threw it on the highway for 2 miles, came back. Smooth acceleration, smooth deceleration, no stumbling. The fuel trims were already pulling within normal range on my live data screen. The truck had completely fixed itself once the math caught up to the metal. I called the guy, told him to come pick it up. He showed up an hour later, expecting to hear bad news. I handed him his keys. I charged him $42 for 15 minutes of diagnostic time. He stared at me. He said, "What about the throttle body?" I said, "The throttle body is fine. It was always fine." The dealership was about to replace a perfectly good part because they did not run a basic adaptive reset before they wrote the estimate. He saved $2,305. I saved a piece of hardware that was going to end up in a scrap bin. The dealership, they lost a customer. Permanently. Now, before you go out and try this on your own car, you need to understand 3 mistakes that I see people make all the time. These are mistakes that turn a 90-second free fix into a brand new problem. So pay attention to this section. This might be the most valuable part of the video. Mistake number 1. Disconnecting the main battery for an hour and calling it done. Yes, this technically resets the engine computer, but it also resets your body control module, which means you lose your radio presets, you lose your seat memory positions, your power windows forget how to roll up automatically when you pull the switch, your HVAC blend doors forget where their physical stops are, your steering angle sensor loses its 0 point. On some newer cars, pulling the main battery without registering the new one means your auto start-stop system stays disabled until you take it to a dealer. On some BMWs and Mercedes, it can even throw your transmission into limp mode for the next 20 miles of driving. The nuclear option creates more work than it solves. Use the targeted reset. Use the procedure for your specific make. Mistake number 2. Doing the reset with a weak battery in the car. Listen to me carefully here. If your battery cannot hold 13.8 volts at idle, no reset procedure on earth is going to fix your problem. The reason your adaptive memory got scrambled in the first place is because the voltage dropped too low. If you do the relearn procedure with the same weak battery still in place, the voltage is going to drop again the next time it gets cold, and the memory is going to scramble again. and you will be right back where you started. Test the battery first. If it is more than 4 years old and the car has been struggling to start, replace it before you reset. A new battery costs $150. The reset is free. Together, they fix the problem permanently. Do them in the wrong order, you fix nothing. Mistake number 3, the one nobody talks about. After you complete the reset, you have to actually drive the car. The relearn procedure clears the slate, but the slate is empty. The computer has no fuel trim data, no transmission shift adaptation, no idle reference under load. It is running on factory baseline numbers from the day the car was assembled. You need to give the ECU about 20 miles of varied driving to relearn. Some highway, some city streets, some idle time at red lights, some hills if you can find them. During those 20 miles, the computer is rebuilding its adaptive tables from scratch, but with the actual current condition of your engine, not the condition it had 8 years ago. If you skip the drive cycle, the car is going to feel weird for a few days. Hesitation, rough idle, jerky shifts, people panic and bring it back to the shop. Nothing is wrong. The computer is just still learning. Drive it, be patient. By the 3rd day, it will run better than it has in years. I want to be intensely clear with you about something, because I am not in the business of selling you false hope. A reset procedure is a diagnostic tool. It is not magic. It is not a cheat code to fix a neglected car. If you have an actual mechanical failure, no amount of computer wizardry is going to repair physical damage. If a mouse chewed through your wiring harness, clearing the codes will not solder the wires back together. If your transmission fluid looks like black coffee and smells like a campfire, a TCM relearn is just going to make the computer realize how badly damaged the clutch packs actually are. If your throttle body is mechanically seized because of carbon buildup, the reset will not unseize the metal. You have to clean it first. Here is the rule I follow in my own shop. The reset is the second step, not the first. The first step is always physical inspection. Pull the air intake. Look at the throttle plate. Is it caked in carbon? Clean it. Is the MAF sensor coated in oil? Clean it gently with electronic parts cleaner. Pull the spark plugs. Are they black, oily, or worn down to the electrode? Replace them. Check the battery voltage. Check the alternator output. Do the basic mechanical work first. Then, after the physical hardware is verified to be in good working order, then you do the reset. Because the reset only fixes one thing. It fixes the math. If the metal is broken, the math doesn't matter. But if the metal is solid and the math is wrong, the reset will resurrect that car. I have seen vehicles that had been declared totaled by the dealership come back to life from a 90-second procedure. I have also seen vehicles with destroyed engines walk out my door unfixed because no software trick can rebuild a thrown rod. Understand the difference between a software glitch and mechanical destruction. That is the entire skill. Cars built before 1996 did not have this problem. An old carbureted Chevy didn't need a laptop to tell it how to idle. It was purely analog. If a part broke, you swapped it. You drove away. But today, we are driving rolling computer networks. The hardware and the software are completely dependent on each other. If the metal is solid but the math is wrong, the machine fails. Knowing how to reset that math is the ultimate defense against an industry that makes billions of dollars swapping parts that aren't actually broken. Now, I want to hear from you. Drop a comment down below and tell me one of two things. Number 1, have you ever paid for a major repair only to find out later it was just a sensor or a software issue that could have been fixed in 90 seconds? I read every single one of these comments, and I cannot tell you how often the answer turns out to be yes. The stories you guys send me about what dealerships have tried to charge for, it blows my mind every single time. Or, number 2, what do you drive? Year, make, model. Because there are some specific brand procedures I did not get to in this video. Subaru has a completely different reset that involves the brake pedal. Volkswagen and Audi have a sequence that uses the cluster menu. Nissan has a multi-step throttle valve closed position learning that takes 7 minutes to do properly. If enough of you ask in the comments, I will make a follow-up video covering exactly your make and model. If you learned something today that you didn't know this morning, that is the entire point of this channel. We exist to keep you out of the dealership service drive. We exist to put money back in your pocket. So if any part of this video saved you from a stupid repair bill, do me one favor and hit that subscribe button before you click away. It is the only thing I ask. And in the next one, I am going to show you something that is going to make you furious. There is a specific sensor inside your engine. It costs about $20. When it gets dirty, your fuel economy drops by up to 20%. Your acceleration goes flat, your check engine light flashes intermittently, and dealerships consistently misdiagnose it as a failed transmission. I am going to show you exactly where it lives, exactly how to clean it, and exactly the reset that has to follow. If you are still here at 31 minutes, you are going to want to see that one. Stop throwing parts at phantom problems. Keep your tools clean, and I will see you in the next one.